Starting with this problem, this is the third problem of today's Leetcode weekly contest, House Robber 4. We have already seen some house robber problem. Houses being robbed by a robber, and you cannot rob adjacent houses. And then there is a capability of a robber is defined as the houses that he is picking to rob, and the one house which has maximum money among them. That is the capability of a robber. The maximum amount of money he steals from one of the house that he robbed, and you have to overall minimize this capability, and you have to return that minimized capability as your answer. So you have to minimize the value of maximum money, right, from one house. So this is the thing, and nums array contains the uh, money present in house. K is the number of house that robber wants to rob. So let's take out these two cases. First case is more simple because it's already sorted. There is a okay, so first of all, like, let's just directly state that whenever you want minimum of maximum, 90% of time you use binary search, and that's what it is over here, because you have to minimize the value of maximum house that you have to choose only two houses, right? You can choose any two houses. You can choose 5 9. No, you cannot choose 5 9. You have to choose alternative, like, not adjacent houses. So you can choose 2 9, you can choose 2 5, you can choose 3 9. No possibility, I think. So maybe there is more. So 3 9, and yeah, I think that's it. So among these you can pick any two houses. I mean, this any possibility you can choose, but 2 5 is good, because in this maximum 2 9 9 is maximum, 3 9 9 is maximum, that is big. But 2 5 5 is a maximum, which is smaller as compared to 9. So that's why 2 5 is my not answer, but 5 is my answer, because 5 is the maximum capability. Like, yeah, actually maximum capability, like, 5 is capability, and it is minimized of all. Like, the capability values, if I write, it is 9 for this one, 5 for this one, again 9 for this one. So you have to take minimum of them, so that's why you have to take 5. Now, how to do this? Binary search, but where binary search? So observation one is, a binary search would be up to these index, because your answer is coming from, answer will always be one of these numbers. Okay, will always be one of these number, 2 5 2 3 5 9. Why? Because, yeah, this is the houses that you can pick, and any, like, you have to pick two houses. So which two houses you pick, that we'll see. So observation is so basically these four numbers I'm representing as index of their number. So let me just quickly write indexing over these points. So this is my zero index. This is 1 2 3 4. Okay, so three indexes. So I can either choose, so this is my low value, this is my high value, like how we do in binary search. So this is low value and this is the high value. Okay, and then after this, what, mid value, you will say ki you will try to find the whether this 5 is good. Okay, whether this 5 is good, ki 5 can be my answer. Yes, 5 can be my answer. So like, okay, and then after which you will say you will try to minimize the value more. So you will say, can 3 be my answer? 3 cannot be my answer, because up till 3 you cannot pick two elements, in this array, which are, let's say, you cannot pick 2 3 because they are not adjacent. But if the 2 9 5 and 3, you can pick 3, you can pick 2 comma 3. That's why the 3 will be answered. In that case, you will try for 2, which is not answer. Okay, so how you'll do that? So first point is clear. Let me just again do this. So the point would be that, let me write the steps also. First step is to generate a sorted array, because currently the array was sorted, so you did not need the sorted array. But why you need the sorted array? You need sorted array to go in the order wise, like, 0 to you need to go for 3, and have this kind of thing into your mind. Because why, when we take or otherwise, if you don't want to take sorted array, you can take just random numbers from 0 to 10 raised by 9, because that's how we do generally in kind of binary search. Because we know, but now we know that the answer is going to be one of these. So let's because there would be, the splitting point about the binary search. There is a splitting point concept, like, till this point answer is no no no, he's saying no, he's saying no, but then answer becomes yes yes yes. So this is the splitting point is always possible in kind of sorted or array. Whenever the given array is not sorted, we try to do it on ranges. But now it's some kind of a question that instead of ranges, we can just sort this array and do on that. So first generate a sorted array. So it will look like, for this one, the sorted array will look like, 2 3 5 9, 2 3 comma 5 comma 9. After that, you will now go for low as 2 and high as 9, and then we'll see. So after generating a sorted array, so step 2 would be just a binary search on this array. Binary search for good value, bind search for good values, bind search for good values. So good values, first you'll find good value 3, it is the good value. And then you'll try to first you'll find yeah, so you cannot reduce it, so that's your answer. So let's try to do this. How you will find good value as 3? So you'll making a good function, so you'll be iterating on this one: low, high, mid, and whether good is mid is good or not. So good of mid function would be this, that you have to go you have to take alternate houses. So you will say ki I'm taking minimum houses. Am I taking minimum houses? Yeah. So on this original array you have to take houses which are less than m value. Okay, take houses which has less than the given value, the good value. So only how much are there? 2 is there and 3 is there. So these are your possible possibilities, like 2 and 3 can be the only houses which has lesser than or equal to 3. And we, if we wanted, let's say currently we want 2 house only, like k is equal to 2, so that's why this is still possible. But if we wanted k is equal to 3 houses, so only 2 houses are such that, so you cannot have 3 houses, so that's why 3 is not fine. So you will try for 5 then. So that is the thing. So you will go all I from 0 to n, basically on auto I in original array. You will see ki if this I is lesser than my current my required value, if this I is lesser than my value which I want, so I can take this, and I cannot take its adjacent one, because this is the original array. Original array is like how originally houses are present. It's not like I sorted this, I make 3 for 2, like it's just for the different thing. But originally the houses are like so you will say you cannot, if you've taken 2 you cannot take 9. So you'll do I plus plus. Whenever you take, you'll do just I plus plus, or basically move to the next index. Okay, instead of just moving to next index, move to second next index. So you'll do something like that: index id plus equal to, yeah, plus equal to 2. You'll check for the next and then you'll try to pick them. Can I pick it or not? If you don't pick it, then keep on moving just normally, normal move. Or when you take, just step 2, take a step of 2, right? So this is the logic. And then you'll count how many numbers, how many count houses you can take, like that house you can take. And if it is greater than the required houses that you wanted to take, which is k obviously, which is fixed, so it's good. So that is the whole question, and let me just code it up, or you just show the code. So first thing would be, there are two ways to write l is equal to 0, high is equal to n minus 1, and I need a sorted vector. So you know you could have done this without sorting, just by taking ranges. So but because of taking ranges, you cannot have that. So vector v is equal to, let's say, num I created, and then I sorted this v dot begin and v dot end. So I'm trying on this V array, like which is the good value possible. So while my L is less than high value, I'm calculating mid as equal to L plus H upon 2 value. And if my good is my mid, then I'll say key, okay, this is not mid, just basically value of mid is, because mid is just indexing, like in this case. But V of V of M has to be good, that it has at least k number of houses lesser than that in the original array, after taking the care that you don't take adjacent elements. So a good element of int, there is a val of house, you can say like house cost or whatever, and int k you want that for checking. And original array you want, I will write it as og. This is the original array. And like now you'll start on iterating I is equal to 0 and I less than n and I plus plus. If this value current og of I, this house value is lesser than your, or equal to, even equal to your value, you can take this and you'll just do I plus plus, or you can do C plus plus. And then the C is basically counter, which you are storing key how many houses are like such. And otherwise you don't need to do, just to move forward. And at last you'll just return your counter is greater than equal to k or not. That has to be greater than equal to k. I think you should write n also. N is your size of og dot size, and I think it should be fine. And now over here you are passing k and you're passing og is your nums array, and anything else. So if it is good, you'll try for the lesser one. So h is equal to m minus 1, otherwise l is equal to m plus 1. And then you will need to return, let's say, uh, what original or what. No, basically you are trying on this vr, so you'll return v of l. And there's a thing that you have to do lesser than or equal to. Let's do it, and let's try to run this code on 3 cases. And then, okay, sorted is not defined, it's sorted. Okay, n is not defined. Yeah, sure. So int n is equal to v dot nums dot size or v dot size. And 252, let's try to sum this up. I think it's pretty simple question, but yeah, just was observation. Okay, accepted. So this was observation that these are the sorted order you will try to keep houses, and then check for a just check function is very simple, that move in the original array, try to pick the adjacent elements, and obviously you will try to pick the elements which have lesser than value than this, and then just to see all the elements which have lesser than value than this, and just take those don't take adjacent, so just do I plus plus, and total count should be lesser than equal to, or should be greater than equal to k. Okay, so that's about it. Okay, bye.